So, how many has worked in Linux before? All right, how many are experts? No one? There's always like one who's like finishes the lab in half an hour. Good, then I'm gonna be here till 5. So this is an introduction. Remember that, I don't expect anyone to be an expert after these 2 days or after this week. So don't be afraid if you think, how am I going to remember all these small details? And you're not supposed to. Don't take notes, don't write down, oh, if it's -L, it means the long format and these kind of things. Don't sweat it. You're gonna be Googling these things for years. I still do. I've been working with Linux for like 15 years. I still get stuck on stuff. But then you just Google and in 2 minutes you see the answer and then you use it and then you don't use that thing for 5 years and then you forget. Next time you just Google it again. So don't be afraid if it feels overwhelming. No one expects you to know all this stuff by heart. So, oh, you're right. I thought we were on the wrong lecture first. So, why do we want to learn Linux? And that is because we're going to be working at UPPMAX. So I'm just going to take a peek and see if this is the wrong. Oh, it looks good. It's the right one. They start off kind of similar. So I'm going to start off the Linux introduction with talking about the UPPMAX, which is the topic we cover after lunch. So UPPMAX is the Uppsala Multidisciplinary Center for Advanced Computational Sciences. And that's a long way of saying the Uppsala Supercomputer Center. And that is where we store all our data. And that's where we run all our programs. And they have cluster computers, and it's pretty much ordinary computers. They're just connected with a very fast network connection. They have 3 of them at the moment. So it's Rackham, Bianca, and Snowy. And the one we'll be using during the course is Rackham. And later on, if you get your own project, if you have human data, you're probably going to be working on Bianca. And if you have any kind of else data that is not GDPR regulated, then you can be on Rackham. They work pretty much the same way, so it doesn't really matter which one you're on. And these computers all run Linux, and that's why we have to learn how to use that. Otherwise, we can't use these big computers. So why do we want to use Linux? Why can't they just use Windows or OS X like everyone else? And it's mostly because it's a very powerful way to work, to use this command line interface. Because when you do programming, you type commands, right? And it's super easy for a computer to type. You can type much quicker than we can. But it's a bit annoying to describe for a computer how to click with a mouse and which button it should press. And what if someone moves that window 1 centimeter to the left and everything is off? But typing commands, you don't have all those problems. You can just program away. And Linux is a very good place to do this because it's built ground up to be a multi-user system. So on UPPMAX, we have maybe 200 concurrent users all running on the same machines. I think Windows is catching up, but it's not really there yet, especially not the desktop versions, how to handle multiple users. So it would be just a waste to run something else. And OS X is based on Unix, which is pretty much the same thing for all things we care about. And almost one of the bigger points is that there are so many softwares available for Linux that it's free to use. So it's open source and you can just download. And especially within research, everyone wants to share their work. You make a program, you make a publication, then you want everyone else to use it for free. You want to spread your software. And a good thing with Linux is that even in like in poor countries somewhere else in the world, they can use Linux because it's for free. They can just download. They don't have to pay 1,000 crowns to get a Windows license. They can just download Linux and use it for free. And in my opinion, I mean, it's much better than Windows and OS X, and it's free, so why wouldn't you use it? So this laptop giving the presentation is running Linux as well. And it looks like an ordinary computer. You have a desktop and you have web browsers and everything. So this is the graphical part of Linux. Looks exactly the same way as any other computer. It works exactly the same way as well. So you could switch tomorrow if you want to and just use the graphical user interface. This is the other part of Linux, the command line one. You don't have to be in this mode if you don't want to. You can do a lot of stuff here, but I mean, I'm contemplating installing Linux on my aunt's computer, or on my mother's sister, not the animal. because she only uses a web browser. She wants to do internet banking and watch Netflix. And why would she have to pay 1,000 crowns to get Windows? It's just a big waste. And you don't have to be in this command line interface that looks scary. You don't have to. You can, but it's not forced. Has anyone seen this before? It's files and folders. So this is the way almost every computer works. You have files and folders, and it's no exception with Linux. People get scared when you have this command line interface where you have to type to go places, you have to type to open files. But just remember, I mean, it's the same thing. You're used to double clicking a folder to go into it. In the command line, you're going to be typing in the command, but it's no different. People often get lost when they don't have this like overview like you do here. You see all the files, you see all the folders. In Linux, you see like what's happening right where you're standing. So the first command we're going to learn is how to look around in Linux. And that's by typing ls. It stands for list directory or list content. And down here, you can see a graphical representation of what we're doing up here. So here you can see this is the command line, it's called. It's going to look something like this. You're going to have your username, @ and then the name of the computer you're working on. And then it's going to say which folder you're standing in. You could say only this folder's name, or sometimes you can have the whole path. Doesn't matter which. Then you have this $sign that says, okay, so here the information stops, and now you can start typing. So in all instructions, when you see a $sign followed by a command, you're not supposed to type the $sign. It's just to show that, okay, this is the command line. You're supposed to type the command afterwards. So if you're standing here and you're wondering, okay, so which files do I have in this directory? So then you type ls and press enter. So this is what you would have seen in a graphical interface if you just double click the dir directory or that small plus sign next to it. And in the command line, you get this just list of files. If you have lots of files, this line becomes very long and it starts stretching out until you reach the end of the window. Then it will start a second line and a third line and a fourth line. So you have a big matrix of file names. That's kind of annoying to search in. If you're looking for a file, they're sorted in what do you call it? Alphabetical order. But if you have to search line by line, it's annoying. So if you add this -L option to ls, you get the long format. That means you get lots of extra information and you get a vertical list. So you no longer have to search in 2 dimensions. You can just start from the top and go down until you find the one you're looking for. And the stuff you have over here, you have the modification date of the file. So January 5th, 1344. Here's the size of the file in bytes. So 28 kilobytes. And over here you have the ownership information. So this is the user who owns the file. This is the group who owns the file. And these cryptic things over here describe who's allowed to read and write to the file. Then we have the cd command. So cd, that's the equivalent of double clicking in a file browser. If you double click a folder name, you go into that folder, right? Here in command line, you just type cd and then the name of the folder. So if you're standing here in a directory called dir, and we type cd directory1 and press enter, we can see that nothing happened. It just updated this thing here. So it says we're now standing in directory 1. And if we type ls in this directory, we can see the files there. So we don't see these files anymore because these are located in dir. Now we double clicked directory 1 and now we see these files. You don't have to take only one step at a time. You can take multiple steps. So here, if we... Was that me, right? Don't think so. No. So we're standing in directory 1 and we want to go to second directory. We could type cd ... and press enter. That means go one step back. So go up one level. So that would take us back to dir. And then we can type cd second directory. Then we'll go into second directory. Or we can do like here that we take 2 steps at the same time. So we type cd ... and with this slash. The slash is a separator between following. Pretty sure that was me. No. And if we do this, cd will just take this list of file names. it will split it on all the slashes, and I will do them one at a time. So cd dot dot, okay, cd second directory, okay. So this is just convenient way so you don't have to type multiple commands and take one step at a time. You can say, go to that directory over there, and then it will just go there. And if you type ls once again, you will see the file is in the directory you're standing. And you don't have to go to a directory to see what's there. You could just tell ls, I want to see the content in this directory. So you don't first have to cd there and then do ls. You can do ls directly and just say where you want to look. So ls-l, and then the path to the directory you want to look at. So if we're standing in second directory and we want to look at the content of directory 1, we'll say ls-l dot dot to go up one level to this dir directory, and then directory 1 to go down into that directory. Sometimes you get lost when you type cd and move around, and you can know that, okay, I'm in a directory called dir, but where is that located? Then you can use pwd. It's kind of like the GPS of the file system. It prints out the working directory, so the directory you're standing in. And in this case, we can say that this dir directory was located in home, dalo, globe, work, test area, temp, dir. So it's not any other directory called dir. And if you type cd directory 1 and then do another pwd, you can see that the only thing that changed is that you took one step further into the file structure. So you're one directory deeper. And if you type cd dot dot, then you remove the last one here. And if you do dot dot again, remove the second last. You can do dot dot slash dot dot slash dot dot slash dot dot. Then you end up over here somewhere. So on these paths, so there are two different types of paths in command line Linux, and they're called absolute paths and relative paths, and they're both useful. So the absolute paths, they always start with a slash, and relative ones don't. That's how you tell them apart. So if it starts with a slash, it means it's defined from the root of the file system, so from the beginning of the hard drive pretty much. So yeah, in slash home, download documents results, or Proj G2019-031 no backup. This is kind of like an address. If I say Husargatan 3 in Uppsala, Sweden, it means this house. Doesn't matter where you are in the world, it always means this house. And that's not the case with relative paths. Those are relative to where you are standing at the moment when you're typing the command. And as you see, they don't start with a slash, they just say, yeah, like dot dot to go back one level, or no backup if you have a folder named no backup in the folder you're standing. And this would be the equivalent of a direction. So if someone asks me, how do you get to BMC? I would say, oh, you go 4 blocks to the right and it's the second house. That kind of depends on where you are. I mean, if you're in Sydney, that's not going to be the case. You're going to end up in some other house. They're both useful. So use whichever one you want, and you can use them interchangeably. So that's it for the navigation commands. You have ls for looking around, cd for walking around, and pwd to find out where you are. Now we're going to start with the interaction command. So okay, you're going to do stuff with files. So a common thing is copying files. Has anyone copied a file before? One or two people shaking or nodding their heads at least. Yeah, we didn't have any experts in the class, right? So now we're going to learn how to copy a file. So in Linux, you just type cp, stands for copy. And the way it works, the syntax of this command is that you type cd, the name of the file you want to copy, and then you make up a new name for the copy. So let's say that we have a file structure that looks like this. So we're standing here in a folder called paper, and we want to copy this file, mytext.txt. So then we type cp mytext.txt, then we make up a new name, we can call it whatever we want, copy of mytext.txt. And the end result will be something like this, that we still have mytext.txt, but for now we also have a second file here called copy of mytext.txt. And you see it ended up here in the same folder we were standing in because we didn't tell it to put it anywhere else. You could have done something like this, use absolute paths or relative paths, doesn't matter. So if we say cp /home dalo test.txt, so okay, so home dalo test.txt, and we want to copy this file to one level up from where we're standing. And we're standing here, so one level up would be the my docs directory. So the end result here is that we still have the test.txt, but now we have a new file here in my docs, and it's also called test.txt. And you see here that we didn't specify a new name, we only specified a new location. So in that case, the computer is going to assume that, okay, so they want to put it over there and they want to use the same name. So it's just going to reuse whatever the original had. And for moving files, it's the mv command. It works the same way as cp. It does exactly the same thing, but it also removes the original file. That's the only difference. So if you type mv/home.test.txt, and we want to put it in 2 levels up my docs. Okay, so home.test.txt. We want to put it in 2 levels up from paper, so 1 level up, 2 level up, and then into my docs. So now we kind of backtracked. That's fine. The computer doesn't really care. As long as this is a valid path, the command will work. And we didn't specify a new name, so it's just going to keep the same name it had before. But now we don't have the original anymore. And that's the only difference between copying and moving something. Otherwise, it works exactly the same. Yeah, and if you don't specify any paths, it will assume that you're operating in the folder you're standing. So mv test.mytext.txt, and then copy of mytext.txt. And result is that you no longer have mytext.txt, you only have the new copy. You moved it to a new name. And this is how you can rename files in Linux. You just move them to a new name in the same folder. So when you want to look inside files, if you double click a text file, it will open up text editor or notepad on your Windows or OS X computers. Here on command line Linux, we have to use a program called less. There are many programs for viewing files. Less is one of them. So just type less, the name of the file. So if you had a graphical interface, you would get this, buttons and tabs and text. In command line Linux, it looks like this. You see the content of the file in the terminal. And then this block here where it says end, this is just less way of telling you that this is the end of the file. There are no more blank lines at the end. In this case, it's a very short file. If it's long, if it's multiple pages, you can scroll up and down using the arrow keys. And then when you want to come back to the command line and type commands again, just press Q to quit. Otherwise, you'll be stuck in less and can't really do anything. If you don't want to get stuck inside a program, you can use another program called head. Head is made for viewing the top of a file, so the top couple of lines of a file. Because maybe you know that you're looking for a file, you don't really remember the name of it, but you know kind of how it starts. Then you can use head and the name of the file. So if we're standing here and we want to take a look inside test.txt, we just type head test.txt, and then the computer will print out the first 10 lines of this file. We just print it directly to the terminal. And then you're back on the command line. You don't have to press Q or anything. You will see all the content here. And if you want to see not only the first 10 lines, maybe you want to see your first 1,000 lines or something, you can use this -n option. So -n and then the number of lines you want to see. So in this case, the first 3 lines. And there's of course another command, I would say a bit more useful than head. It's called tail, and it shows you the last couple of lines of a file. And it works exactly the same way otherwise. So if you type tail test.txt, you see the last 10 lines by default. And if you want to see a different number, you use the -n option. So why is tail more useful than head? And the reason for that is that if you're running an analysis, those programs will usually print their progress to a log file. So you can see that, okay, so it's in stage 4 now. Okay, good. Then it's probably finished soon. And all these log files, they're always updated at the end of the file. So the most recent information is at the bottom. So if you use tail, you get the most recent lines of that log file. If you use head, you only see, okay, starting the analysis, and it will never change. But the last lines will always be the latest. So head, tail, and less, they can only view files. You can't edit files. if you want to edit a file, you have to use another program. One of them, which is quite user-friendly, it's called Nano. Just type nano, readme.txt. The reason why we have separate programs is that if you want to read a file, you can just start reading from the top and show the content directly on the screen. If you also want to be able to edit a file, you first have to load the whole file into memory, because you can't save the file without having the whole file in RAM. So if it's a large file, a couple of 100 megabytes, it's going to take like a minute to read it to RAM for the computer. If you ever try to open like a 10 megabyte text file on your laptops, it takes a while. So if you do this to gigabytes or terabyte files, it's not possible. But you can use less on a 10 terabyte file, and it will show the content instantly on the screen. And it will only read as much from the file as you can fit on the screen. So that's why we have two different types of programs. So viewing programs are instantaneous and only reads what it needs, whereas editing programs, they have to load the whole file into memory. So if you type nano, then the name of a file, it will look like this. And you think that, oh, finally I have buttons I can press, but you can't. It doesn't notice any mouse clicks. So otherwise it works exactly like Notepad or TextEdit. If you start typing, it will just show up here. And if you save the file, it saves to the file on disk. You can't use the mouse to move the cursor, so you have to use the arrow keys on the keyboard. You can go up and down, or right and left. I was a bit afraid of Nano in the beginning because I got stuck in there. I didn't know how to get out. It says down here, like, okay, so do the hat sign and X. And I tried the hat sign and X, but it didn't work. Turns out this hat sign thing, it means hold control. So for exiting, you press Control X. And I didn't know how to save the files either, because there's no save here. That's because someone thought, oh, let's call it write out instead. That's intuitive. So if you want to save the file, press Control O and then Control X. If you try to exit without saving the changes, it will ask you, do you want to save the changes? Then you can press Y, I think, or Enter. So then we have RM, stands for remove. So there's no trash bin in Linux, so don't remove things you want to keep, because then they're gone. And just type RM, name of the file you want to remove. So either in the directory you're standing, so readme.txt, or RM, this relative path, so 3 levels up, file1.txt, or an absolute path. All of them works. Then we have something called wildcards. And this is when you want to do stuff on multiple files at once. And it's the star sign on your keyboard. It means anything. And what does that mean? And it means that, okay, so you can tell ls, show me all the files that start with anything followed by .txt. So all file names ending with .txt. So this is like giving ls a filter. So show me only the files that end with .txt. Or you can say, show me all the files that start with the word file, but I don't care about the file ending or if it's a longer name. So this is a good way to show, like, show me all the PDF files here, or show me all the CSV files. And it's not only ls that can take these wildcards, it's pretty much any command in Linux. So cp, if you want to copy all the text files from one directory to another, you can do cp star.txt. Then you specify a destination. Here you can't specify a new name for the files. It will reuse the same names. And this is where it gets dangerous with wildcards, when you start doing rm and star dot something. So if you want to do rm and use a wildcard, always do a ls with the same pattern, because then you see all the files that is going to be deleted. So then you know if you're not going to delete your thesis or something. So tab completion. This is super important, as you might notice. If you remember anything from this lecture, remember this, tab completion. So never ever type a path or file name without using tab completion. Like 90% of the time someone does this during a lab, it's because they didn't use tab completion. So remember that. So what is tab completion? It's a very good way to get the computer to work for you. So when we type, we use our sausage fingers. We try to press the buttons, and when you miss a button, you misspell something. You don't remember the name. The computer doesn't do that. It doesn't have fingers. It just types. So if you want to type a path or a file name, don't type it out yourself. Type the first couple of letters of it, and then you press the tab key. So the tab key is left of Q on your keyboard. You can press it as many times as you like. And what happens when you press it is that, okay, so we type nano fi, and then instead of typing out file1.txt on our own, we just type fi, and then we press tab. And when we press tab, whoops, the computer fills in the rest of the name for us without making typos. And you see here, it only filled in this file. It didn't go all the way file1.txt because the computer is not psychic the way we wish it would be sometimes. So now you have to decide which is going to be the next character. It's going to be number 1 or number 2. And you see that it stopped here and it's just waiting. So if you press tab a couple more times, you can press it as many times as you like, it will print out all the files that are matching the pattern you typed so far. So then you see, okay, so what are my options? Should the next character be a number 1 or should it be a number 2? So then you type 1 on the keyboard and then you press tab again. I actually pressed tab. Should press the right arrow. So then you see, then it could fill in the whole file name for you. And if you notice here a difference, you can see that the cursor is now one step removed from the file name. There's a space after the file name. That's the computer's way of telling you there was only one single file matching this pattern. Whereas here, there was no space. That means there are multiple files matching this pattern. But now we could fill in the whole name and there are no typos. It's quite easy to type a small file name like this on your own. I mean, it's pretty quick. But if you have a long path, then it's harder and it's more easy to get typos in there. And a good thing also is to test your path. Does it actually work? Did I make a typo? If tab completion works on your path, it's correct. If it doesn't work, that means that you have a typo. Then you delete maybe 20% of the file name and try again. Eventually it's going to start working. And then you can continue typing the path again using tab completion. So then we have another program called Top. Have you ever used the activity monitor on your computer? Or task manager in Windows? It's a way to see how hard is the computer working. This is like a big wall of text, so you can't really tell that much from it when you just open it up. The good stuff is down here. So each line here represents one program or one process running on the computer. And the columns here describe different things. So over here you have the command column, which says what's the name of the program running. And we can say here's one called Invaperco and creatin steward.exe and so on. And this column time says for how long has it been running. Then this mem column is how many % of the total memory of the machine is this program using. So 0.2%, almost no memory usage. Good. And here is the CPU column. This is maybe the most important one. I would say ghosts in here. So these two columns are probably the most important ones, the memory and the CPU. As long as the CPU is working at 100%, you're happy. That means the CPU is not waiting for a slow hard drive or slow network or something. What could happen is that your memory runs out in the machine, then you will see all the CPU usage will drop to like 1% or less. You don't want to run out of RAM, then you might as well just terminate your process. And over here you have a bunch of other information that's not really important. Here you can see the name of the user running the program if you want to complain to someone using too many resources or I don't know. Up here you have some general information about the whole computer. So you can see it's been, here's the uptime, so 21 hours, 27 minutes, 48 seconds. Oh no, actually that's the clock, and here's the uptime. So it's been running for 37 days without being restarted. And it's 2 users, and the load says, okay, so on average, how much is this computer being used? So you can see, is the load on the computer high only now, or has it been kind of consistent lately? I think this is the last minute, the last 5 minutes, and the last 15 minutes. Or it could be in the opposite order, I don't remember. And down here, you have the memory information that can also be quite useful to know. So here it says it has 24 gigabytes of RAM in total, and almost 18 gigabytes is being used, which means it's almost 7 gigabytes free. If this amount free is close to 0, then you have problems. You have to do something. And then you're probably also going to see that your CPU is running at 0%. So might as well just abort everything. So and then we also have a program called MAN, stands for manual, because maybe you don't remember all the options. Is it -L or what is it to ls? What does that option mean? So it's the manual for programs. Just type man, the name of the program that you're interested in learning more about, and press enter. Then it will open up one of these less windows. So you can scroll up and down using the arrow keys. So they're kind of dense. So the first time you open up, it's like, how do I even read this? But they all look the same. So when you read 4 or 5 of them, you kind of get into it. So here's just a general information. Here's the syntax. So you type ls, and then if you want to, because it's hard brackets, that means it's optional, you can give it options. And if you want, you can also give it a file name. And down here, it describes all the options. So for instance, the -a option or --all means do not ignore in entries starting with a dot. So those are hidden files. If you rename a file so it starts with a dot in the beginning, it will not show up when you type ls unless you also give it this -a option. And it also will not get stuck in these wildcard operations. It's like rm star.tmp will not remove the one starting with a dot in the beginning. So it's a way of hiding files. It could be for your colleagues, or if you don't want to see it, if it's just a settings file or something. And then when you're happy, you press Q to quit, and then you're back on the command line. So how do you exit? Well, just type exit. You could also press Control D, which means the same thing. We'll just close down the current terminal. Because if you have multiple terminals open, which you should always have 2 terminals. It's kind of like having 2 hands. It's very convenient. So don't get stuck in only one terminal. So if you type exit, it will exit only that terminal. It won't exit your other terminals. They're all completely independent. So, summary of these commands. So CP for copying, MV for moving, less for viewing, nano for viewing and editing, RM removing, head and tail will look at the top and bottom of files, wildcards for operating on multiple files, and you should always use tab completion and top to see all the active processes on the computer, man for looking at the manual, and exit to close down the terminal. All right, everyone knows that by heart now? Good. So if you get stuck in, if you don't remember, just Google what you want to do, like how to rename multiple files in Linux. And you'll see a couple of pages like this one. I wouldn't go to this one because this is probably going to be a blog post, kind of, like recipes. First explain all the gardens in Italy or something before they give you the recipe. Same thing here. It will just say, oh, maybe sometimes you want to rename blah, 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 blah. And if you go to these ones called Stack Exchange or Stack Overflow, then you get the correct answer directly. And you don't have to sift through all this fluff information. So now we're going to start doing the lab. So the first thing we're going to do is connect to UPPMAX, because that's where we have all the files. And I think almost everyone did this before coming to the course, that you connected to UPPMAX and you created a folder with your name. If you didn't, we don't really know if this will work for you, but we're going to find out pretty soon. Otherwise, if you could do that, no problem. You're a member of the project. You can log into UPPMAX. You have your password, everything. So you'll be using a program called Terminal in Linux or OS X, or if you're on Windows, you can use a program called PowerShell. It should be installed by default. And you just type SSH-Y. This capital Y thing means enable graphical transfer on this connection, which won't work in PowerShell. But it's good to always use that one, because one day you're going to actually have graphics you want to look at, and then you will be using a different program, maybe called MOBA Xterm in Windows. So just use this one. It doesn't slow anything down. It just gives you more options. And then you have your username at UPPMAX at rackham.uppmax.uu.se. So this is in the lab instructions. So now we're going to go to the course homepage, which you got on an email about. So this Uppsala instruction page. And you go to the content tab and then go for the lab for the Linux introduction. And if you have any problems, just raise your hand and we'll come by and help you.